Good morning, students. So far in last class, we have to discuss it with that what is the association analysis. Mainly, we have to represent it with association analysis. What are the basic uh, market basket analysis? That is the MBA. In the market basket analysis, already we have to discuss with that support and confidence. Both you have to discuss it in last class, and also you have to discuss with that frequent item sets. So with the frequent item set, which algorithms you have to use? That is the a priori algorithm and FP growth algorithm. Already in a priori growth algorithm, you have to use the mainly with that. You have to discuss with that frequent item sets with the priori algorithm. In the priori algorithm, you have to discuss what is the k equal to 1 and f of k equal to with the I implies to I belongs to I. The intersection with the row of I is always is less greater than or equal to n into minimum support. And if they have to repeat the k equal to k plus 1, and with the priori generation, generating the candidate item sets for each transaction, T belongs to capital T to the subset of pruning, as well as pruning the data, as well as uh, and generation. Both you have to perform it on a priori algorithm. The priori algorithm, how it works, along with the example in today class we have to discuss. that is a simple hash structure. Whenever you have to discuss with the query algorithm, first you have to define the one hash. Uh, Hash you have to generate it, that is hash table. Simply, that is simply you call it as directory. The hash table that stores the candidate item sets as keys and the number of appearances as the value. Initialize the with 0 increment and counter for each item set for that you see in the data. See here the item sets here. This is the example. We show uh, see here. This is the key value uh, 367. That is the key, and the value is 0, 3, 4, 5, 1. So here we have the totally 15 candidate item sets are there with the length of 3. In the length of out of 15, so the hash table stores the count of the candidate item sets have been computed 145. That is, you have to represent it as 1 or how many times you have to getting the 1. You have to represent it. Here you have to see that is the 1, 124, as well as 125, as well as 159 and 136. Totally how many times? That is the value is 5. And 136, that is you have to represent it as that is the 1. Based on key values, here we have to see uh, which items are repeated in candidate item set. That key values we have to represent it here. And 1 to 4, 1 to 4 generally we have to represent it. How many times 2 is repeated? How many times we have 1 is repeated, and how many times that is the 4 is repeated. So that is simply call it as generating the tuning candidate item sets. They have to represent the key value with the hash function. That is simply can call it as hash tables. You have to use it here, and total value is 367. 367. If you have any how many times, first you have to represent it as 367 one time. That is, you have to represent it. That is the 0. So in all together here we have to give an example. So to how many values are there? That is the we have to represent it as a particular transaction. Total item sets are 1, 2, 3, 5, 6. We have to represent it. This is the here you have to represent it. That is the 1, 2, 3, 5, 6, and it generates the values 2, 3, 5, 6. Most number of items we have to frequently repeated. Those items we have to consider here. that is in level 1, 2, 3, 5, 6 are the, we have to represent it 1, 2, 3, 5, 6. Totally, these are the a particular transaction we have to do. Or 2, 3, 5, 6 are represented frequently have to purchase, and 3, 5, 6 you have to repeat it 2 times, and 5, 6 are repeated 3 times. And here, based on that, you have to represent the enumerating the subsets 3 times per the transaction. We have to find out the hash function value. That is the level 1, 1, 2, 3, 5, 6, and 1, 3, 5, 6, 1, 5, 6. So see here how many times it will be repeated. That is only you have to consider. And then the number of times which item is continuously you have to repeat it. Those only you have to consider in the frequent item sets with the hash functions. See in real-time environment, that is the total 5 transactions we have to consider here in the mining association rule. In those five transactions, we have to consider the items, that is the bread, milk, bread, diaper, and beer, eggs, milk, diaper, beer, coke, bread, milk, diaper, beer. So here, which item is most frequently they have to purchase? So bread is 4 times they have to purchase in out of 5 transactions. Okay, and similar way, milk, how many times you have to purchase it? That is the 4 times you have to purchase it by the milk out of 5 transactions. And a similar way, diaper you have to purchase it by the 4 times they have to purchase out of 5 transactions. So here you have to find out the confidence value, that is the row of milk and diaper and beer you have to represent, that is the 2 times you have to getting, that is the milk, diaper, beer, milk, diaper, beer, you have to represent it. An implication is impression. Association rule and application is expression of the form X implies to Y, where X and Y are the item sets. Milk, diaper, and the beer, we have to represent the values. So milk, diaper, and values you have to implies, or you have to represent the bread, milk with the beer. So how many times you have to repeat it? That is the rule evaluation matrix you have to represent it. That is the support and confidence. The fraction of the transactions that contain the both x and y, the probability of p of xy and xy occur together. Example, see here, if the support you have to represent it as s, s equal to, that is the row of milk, diaper, beer, and out of 5 transactions, 2 transactions repeated, that is the milk, diaper, beer, we have the 2 transactions, that is the third transaction, and the uh, third transaction and fourth transactions are same milk, diaper. Milk diaper beer we have to repeat it. Milk diaper and beer you have to repeat it. That is out of 5 transactions. Total transactions is 5 transactions. That is the 2 by 5. That is the value you have to getting the 0.4. That is the probability for the support. And what is the confidence of the value? We have to find out the row of the milk diaper and beer 2 times, and milk and diaper. So except the you have to represent the conditional probability. Probability of y to x. Y is occurs given that x is also occurred. That is, you have to represent it as so except the out of 5 transactions, so 2 transactions only you have to milk diaper bill, and except the milk and diaper you have to represent it as except milk and diaper have to represent it how many times. 3, 4, 5 transactions are complete have to use it. That is the 3 transactions. That is the 2 by 3 you have to getting the probability 0.67. That is the way you have to find out the confidence value for the rule evaluation matrices. So here a set of transaction T, a set of items, minimum support and minimum confidence values you have to find out. This is the input you have to given to that a particular analysis of a given data. And what is the output you have to getting here? All the rows with items having the support is always greater than minimum support, and confidence is also is greater than equal to minimum confidence. This is the very important point. That is the all rules with items in having support is always greater than or equal to minimum support, and confidence is always greater than or equal to minimum confidence. So this is the mining association rules for the given example. And minimum association rules, generally you have to perform the two-step process here. First one is the frequent item set generation. That is the support always greater than or equal to minimum support. Generate the all item sets rules have. And second one is the rule generation. Rule generation generate the high confidence rules with each frequent item sets, where each rule is partitioning of the frequent item sets into left hand side and the right hand side. So frequent item sets A, B, C, D, and how we can perform that is the if the both AB is there, always implies to CD. That is the rule generation. First, we have to mining association rule. How we can represent? First one is the which items are frequently purchased by the customers. You have to represent it here. That is the frequent item set generation. That is the first case. And the second case, rule generation. What are the items are there? Those items are you have to for those items we have to generate the one rule. That is the rule generation. This is the two-step process we have to use in mining association. And association rule is the anti-monotonicity. We have to represent ABCD. We have to represent it as confidence is the anti-monotone with respect to number of items with the RHS rule. See here, total items are ABCD, L equal to ABCD, and the first confidence value of the first 3 items we have to consider it implies to fourth item, that is the ABC implies to D, is always greater than or equal to confidence of AB. Two items only you have to consider. AB implies to CD, and always greater than or equal to confidence of one item, that is the A implies to BCD. So this is the rule must be followed. That is the anti-monotonicity in association rules. So the rule generation for the prior algorithm. So based on this rule generation, you have to generate it. Just to know, we have to discuss with that candidate rule generated by the matching of rules that share the same prefix of the RHS. That is, we call it as. So for example, here you have to see CD is implies to AB and BD implies to AC. So in these two rules, you have to generate the new rule. That is simply you can say that D implies to ABC. So in the CD and BD, you have the common item is D. D implies to A. What are the here you have the remaining implies which items are there, A, B, and AC. So now A, B total items are 3 items. That is the ABC. D implies to ABC. This is the way new rule, prune rule you have to generate it here. Prune rule D implies to ABC. If it is a subset of AD, AD implies to BC. Does not have the high confidence. See here, this is the uh, representation of the frequent item set. Now more than one items you have the number of transactions. You know those transactions, which items are purchased that you have to represent it as one. Like this way, if the not purchased, we have to represent it as 0. That is the compared representation of the frequent item sets. A number of frequent item sets you have to find out. With the compared representation, to get the value, and maximal frequent item set you have to generate it here like this. So here this is the maximum frequent item sets. If the none of the its immediate supersets of the frequent. See here that is the native border. So here based on that compact representation of frequent item sets, we have to generate the table. After generating the table, we have to represent the compact representation for the maximum frequent numbers. So first one, total items are there A, B, C, D, F, A, B, C, D, E, and similar way number of maximum item sets we have to purchase it. That is the case. That only we have to draw a line. That is the border we have to represent it the maximum item set. Maximum item sets is a positive border you have to represent, and that is the negative border you have to represent it as item sets is not frequent, but all their immediate subsets are frequent. And that is represented as negative border. So that is the pruning and border you have presented totally how you can represent a particular border. And that means which items are most frequently they have to purchase it by the customers. That is represented as, that is the positive border and as well as negative border. Both you have to add it. So కొన్ని products ఏం చేస్తారంటే most of the people they have to purchase, and but it is infrequent. So different always they have don't want to purchase, but out of 5 transactions, 2 transactions only they have to purchase, but frequently they have to purchase by the different people in different times. So that type of products also there, that is the native border products, that you have to represent it as native border product, as well as frequent item sets, as usual you know that is the positive border products. The both will be added, that is the product of frequent item sets. Frequent item sets that are all their immediate subsets of the frequent, and their item sets such that there are immediate subsets are frequent, and all their immediate subordinate sets of the infrequent. Either the positive or negative border is sufficient to summarize all frequent item sets. So here, see here, this is the overall example of the particular algorithm, that is the approach algorithm, or we have to represent it. So here we have to consider that is the immediate supersets of the same support as the item set. For example, here you have the 5 transactions A, B, B, C, D. That is the first transaction only, A, B items only they have to purchase. In the second transaction, B, C, D. Like this way, A, B, C, D are the items. Those items are purchased by the various customers in different transactions. Here you have to consider the only 5 transactions. First one, A only purchased by the how many people they have to purchase. That is simply call it as support. So here you have to consider uh, A is purchased. So how many out of 5 transactions, A is purchased by the 4 people, and B is purchased by the how many people? B is all transactions they have to purchase it the they have to purchase it the uh, purchase it in all transactions B item. So that is the support is 5. And C is the how many people they have to purchase. C is purchased, that is only 3 people only purchased the C item. So that is you have to represent it as 3. And D is purchased by the how many people? D is purchased by the 4 people, that is the D is supports as a 4. Next one. Next, AB. AB is the item set. You now you have to first one individual item set you have to consider. Then two item sets. Two item sets you have to represent it as A comma B and AC AD. So you have to two item sets you have to consider. Next three item sets. Like this way you have to represent it here. So here two item sets you have to represent it as AB is the items